Good morning, Griffins. We're going to continue what we were doing with equations, and we are going to be working with what's called a system of equations today. So we're going to be solving systems of equations by graphing. So to start with, a system of equations is two or more equations. So we're going to be working with basically two equations today. So the solution to a system of equations is going to be a point, and it is written as an ordered pair if we have two solutions. It's called an ordered triplet if we have three, but we're just working with two lines today. So because we're working with lines, it's the point where the two lines intersect. And then when you have a system of equations, you can have no solution. This is going to be two lines that are parallel. We can also have what's called an infinitely many solutions. That means that the two equations are actually the same line, so all of those points on the line are going to be solutions to those equations. So this is kind of visually what we're going to be working with. We have two lines that cross. So if they cross, they have different slopes. So these lines are going to intersect, and that means there's going to be one solution. This middle one shows two parallel lines. That means they have the same slope and different y-intercepts. So these lines never intercept because these lines are parallel, and that means there are no solutions. The last one shows one line. That's because it is actually two lines that have the same slope and the same y-intercepts. So the lines are basically the same, and that means there are infinitely many solutions. Okay, so we're going to graph some examples. So this first one, we're going to graph, they're both in slope-intercept form. So the first one, and I'm telling you that there is no solution, but we got to graph it to prove that. So the slope for the first one is 3. The y-intercept is 2. So I'm going to put a point at 2. And I'm going to go up 3 over 1. And so I have another point. I'm going to go down 3 over 1. And then I'm going to create my line. Put arrows on my line. And that's my first graph. For my second one, the slope is equal to 3. The y-intercept on this is negative 2. So I put a point at negative 2. My slope is 3. So if you notice, you can visually see, and I know my graphs aren't that great, but you could pretty much see how they're parallel lines, and they're parallel lines because the slopes are the same. So this would be an example of a no solution. So on this next one, we're solving with an infinitely many solutions. So on this one, we're going to graph the first one, and the slope is equal to negative 3/4. The y-intercept is 3. So I start at 3. My slope is negative 3/4. Go down 3 to the right 4. So I'm going to also go up 3 and go backwards 4. And then draw my line. And then I'm going to draw my second one. On my second one, it is not in slope-intercept form. It's in standard form. So I'm going to do x, y intercepts. If x is equal to 0, that gives me 8y is equal to 24. So y is equal to 3. Divide both sides by 8. If I have y is equal to 0, to figure out what x is, I have 6x is equal to 24. Divide both sides by 6. It means x will equal 4. So I have a point at 0, 3. I have a point at 4, 0. And as you can see, they're the same line. So I know it's hard to draw two lines on top of each other and show that you have two lines, but these would be an infinitely many solutions. This next one, we're going to have one solution. Because we have one solution, we are going to have two lines that are going to intersect. So the first one, we have m, the slope is equal to 1. The y-intercept is 2. So I'm going to start at 2. My slope is 1, so I'm going to go up 1 over 1. And on this one, I'm going to make the line just a little bit longer than what I did on the other ones because I don't know where the lines are going to actually cross. So I need to make it big enough so that I could figure out where they do cross. The second one is not in slope-intercept form, but I can put it that way. I can start by adding 2x to both sides of the solution. So y will equal to 2x plus 1. So on this one, the slope is equal to 2. The y-intercept is equal to 1. So I'm going to put a point at 1. My slope is 2. I go up 1 over 2. And actually, I'm already at where they cross, so I don't really need any more points. The solution is an ordered pair, so I look at that ordered pair, and it is 1, 3. Now, you can check your solution that if you put in the x is 1 and y is 3, does 3 equal 1 plus 2? And it does. And then x is 1, y is 3. That gives me negative 2 plus 3 is equal to 1. So then I know I have the correct solution. So here's a couple of practice problems for you to do. So on the first one, what is the slope and the y-intercept? The slope will be equal to 3. The y-intercept will be 2. So put a point at 2, up 2 over 3, and then graph this. Try to get a straight line. And then on the second one, I've got, what is the slope and the y-intercept? The slope is equal to negative 2, and the y-intercept is equal to 2. So at 2, I'm going to put a point, and I've already figured out where it is, but I have to draw my line. So my slope is negative 2 over 1. So here's my second line, and I just really need to show where they're crossing. So that is my solution. My solution is going to be 0, 2. And I could prove that it's true. I have 0 for x, 2 for y. So 2 equals 0 plus 2. And if I put 0 for x and 2 for y, I get 2 is equal to 0 plus 2. So that's my correct solution. The last practice problem, we're going to start by doing slope and y-intercept. So on the first one, slope will be equal to 2. Y-intercept is equal to 3. So I'm going to start at 3. My slope is 2, up 2 over 2. And there's my first. I think that's pretty straight. And then on my second line, this y-intercept and slope. Slope is equal to 1/2. The y-intercept is equal to 0. So I'm going to put it as a point at 0. I'm going to go up 1 over 2. Going in this direction, I'm not finding where I'm going to intersect, so I'm going to go backwards, and there's actually where my point is. So my solution is going to be negative 2. My solution will be negative 2, negative 1. So if I put x is negative 2, y is negative 1, negative 1 equals negative 4 plus 3, true statement. And then y is negative 1, 1/2 times negative 2, and that gives me negative 1 equals negative 1. So there's a true statement. So your homework today, you are graphing lines, systems of equations to figure out where they cross. That's going to be their solution. Make sure you write your answers as ordered pairs. So thank you so much. Have a good weekend, and I'll see you back here next week.